Alright, greeting guys. I hope this will be a bit more louder than the one that I did previously. Alright, so I want to finish up vector components, right? Adding vectors, resolving vectors, and the works. Alright, let me see if I bring up. I need something that, no, I need something to just take notes for a while. Can turn on that, please? Alright, let's use the key. Alright, so let's go with this. I'll be using this to take the notes. So adding vectors. Alright, so let me just get rid of all these additional things. Delete notes, delete notes, delete notes. Alright, so adding vectors, see it here. This we are work on now. So any little notes that I might have, I'm going to be throwing it on that side. Alright, so the first thing that you need to know, there are two things we can do: adding, combining. Let's say combining and resolving, because that's the topic: combine and resolving vectors. Alright, so we can, in combining vectors, right, we can add them, add the vectors, and we can also subtract the vectors. Now, a series of internet interruption and all them something that cause us not to effectively gone through this. But I need you guys to go through, especially to Miss Garden. I did remember you, but it has been a very long period trying to sort out things. So I had reserved your replying to you so that to better get this video sorted out. Alright, now I'm going to be using blue vectors of different magnitude. So with this vector we can tell the magnitude, right? And the magnitude for this vector is 14.1. That's the length of the vector. The magnitude for this vector is 15.5. Good? Now we use rulers to measure the magnitude, or the length of the line that we are measuring. Now we'd have used our protractor to catch the direction, meaning at which angle it is going, and see it there. This vector is going at 14.9, my apologies, and this one is going at 45 degrees, and we need to add both of them. What I'm going to use first, I'm going to use the parallelogram method, right? So if I add this vector and this vector, and I'm supposed to add it, I would, this vector right here, the 14.1 vector, I would have identified the head, and the head is right here. And I'll take the tail of the 15.5 vector and put it at the head of the 14.1 vector. Good? Now, so I am basically looking like this. How would I take this? I would have drawn a vector, right, at 45 degrees, and then I'll use my ruler to measure 14.1. For this vector also, I would have get my protractor, measure 14.9 degrees, and then use my ruler to draw 15.5. Now I am using the parallelogram method. So methods of combining vectors. I'm using presently the parallelogram method, right? So let me just go back over here. So I just grab a next vector. First I need to find 45. I need to get 45 degrees. The best thing that 14 degrees, sorry, I need to get this one. The reason being, I would have put my protractor here, right? I would have laid out my protractor here. So I laid out my protractor there, and I measure 14.9. Let's see if I can get back 40.9. And what you'll notice is that it is a bit difficult to manipulate these simulation, right? So I would have put my protractor here and measure 14.9. Good? And that would be the 14.9, right? Repeating, I would have put my protractor here, measure 14.9, then use my ruler and measure 15.5 units. I don't have to measure the 45 and the 14.1. I can just grab this vector, put a vector here, and complete this. Put it right there, lock this. If you notice, locking here to here is 14 by 14.1 at 45 degrees. So if from you catch this one here, and let me use, I'm using orange. From you catch this, the parallel, orange parallel line to this blue line, 15.5 vector there. I just need to just now put the tail of the second vector there, put it to the head right there, and I get 14.1, which is this is parallel, this is the same length, 45 degree. This one is 45 degree, this blue one is 45. So the 14.1 vectors are parallel, the 15.5 vectors are parallel because they are all at the same angle. All I need to do now is to get one vector, put him from there, extend it up here, measure, use a ruler now to measure the length of this line. That would give me 28.7, right? And use my protractor to measure off the degree. So I know that when you add 14.1 to 15.5 acting at their different angles, I am going to get a resultant. This is what we call a resultant. This one here is called a resultant, right? This is the result that I will get from adding 14.1 acting at 45 degree to 15.5 acting at 14.9 degree. See there. This is the Patwa version of adding vectors using the parallelogram law, people. Alright. So we talk about the parallelogram law. Now I can show you by triangle also. How to add the vector. Watch this. I can get rid of this. Get rid of this. Get rid of this for the time being. I was given 14.1 acting at 45.0 degree. 15 and then say add it to 15.5 or 14.9. Good? All I need to do is to take this tail and add it to this head. I get back my 29.2 at 28.7. See it there. That's the triangle method. Alright. So we can, so going over, you see that I can, when combining vectors, you had seen from previous lessons that I can add the vectors and I can subtract the vectors. And we know from previous lessons that these happen in like this. Both of them going in the same direction. Right? You can add them. See there, you had them. If you see the value, what you will see, you had 15, a vector 15 units long going to the east. You have another vector 5 unit long going to the east. 15 plus 5, that gives you 15 and 5 give you 20, right? What I can do, I can turn it around now, right? And I can add them still. This I'll take as positive, I take this as negative. So positive B plus negative A gives me 9. Alright? So and we would have called this a subtraction. While if I have them going in the same direction, they would be addition. So we subtract vectors when they are going in different direction, and we add them when they're going in the same direction, basically. Alright, so we went through that babble, meaning that is good. Now we have method of combining vectors. We use the parallelogram and we use the triangle a while ago. Right? Now, what about resolving? The vectors. Right? Now, resolving the vectors, you will see what you will have is you will have the resultant. You would have had the resultant vector. So these take off this, take off this. So what you have a vector this long, right? You have a vector that long, and you want to know get vectors that breaks up to give you this. And we can instead of using ruler and a protractor, we use mathematical concepts now, right? And the mathematical concept that we can use is the Pythagoras theorem. Right? And how this work? Trigonometry, Pythag theorem. Right? So let me just add that then. Slash trigonometry principles. Like add that. Good? Watch this now, people. Now, I can quickly go and do this. And I get 14 and I get 25. If I add a vector going north at 14 units in size, another vector going 25 units east, right? This will add up to give me this amount, the 28.7. Sir, you're confused. Me no know what I go on. Alright, just look upon this. I can either write, remember, I had that vector. Let's start out with this vector. Right? You can either write it like this, which would be you basically putting it on this line. Good? Or you can write it like that. Notice it's the same thing. All you do is take the magnitude from that side here and put it at this side. Alright? Watch it now. Let's prove that this and this, when add together, you get 28.7. Let's prove it. Let's see if I can do it in here. Alright, so the resultant, that would be the vector, the big vector that we got, right? Pythagoras said the resultant square A. Let me just bear with me there, guys. Copy. Let me just change. Do this fast. What? That. What? Alright, coming back down. Alright, me press the wrong thing. Plus that. So let's change it now. The resultant on the x-axis, the vector on the x-axis, the vector on the y-axis, right? If I want r alone, all I do is put that in a bracket, find the square root now. Square root, where are you? Where is the square root sign? Those are arrows. I think the square root sign over there. Alright, square root. So all I need to do now is get the square root of both sides of this equation. And when I square r, I get r square. I get r. R square square, I get r. And when I square x square plus y square, that all of that is going to fall underneath the square root sign. Watch this now. I am going to put in some values now. So r equal, let's drop this, copy it, put it down here. So changing these bracket signs to square brackets for a reason, you soon see why. Right? Well, I didn't have to change it. So we have 25 on the x. This vector is 25 units long. So let's put it in there. 25 units long. The one on the y-axis, 14 units high. Let's do the maths now. R is equal to, okay, but this, copy, paste, reach for my local calculator quick and fast. So 25, right? We say 25 times 25 will give us 25, 25. Do the maths, do it over there. So go so 25 times 25 give us 665. Take off is 625, sorry. Alright, and 14 times 14 that give me 196. So 196, cut this, copy 196 plus 625. Let me just grab this again to see that the right thing I am doing. 25 square, 625 plus 14 square, that give me 821. So r equal, and find the square root of 821. I get 28.65, and I can say r, reach for the approximate sign there, right there again. Approximate is approximately, when I round it off, I get 28.7. See it? 28.7. So I go back to that. Alright? That's what we call resolving. So you have the one vector and you break it up into the components where you mean, or we resolve it. Alright? Now if you want to know how you will get back the 29, if you did not get the 29.20 0.2 degrees, 29.2 degrees, it is simple. All you need to do is use a trig function called tan. Tan, right, theta. Let me see if I can find that quick and fast. Tan theta is equal to y divided by x. The y value divided by x. That will be tan theta equal to, the y value was 14 divided by 25, right? Then you would have said now theta, right, equals, and when the tan go over the equal sign, it's going to become -1 to the -1 power. Let me see if I can put in 1 and get the negative. 1, right? Put the negative, comma, 14 divided by 25. You go ahead and put that in your calculator now. Go ahead, put that in your calculator. You should get tan, right, but this, copy, paste. So you first say 14 divided by 25. 14 divided by 25 give us 0.56, right? So that means this theta right here is going to equal to, so what you do now, you go on a scientific calculator, right? Not the adding machine, a scientific calculator. Look for the shift or second, press it, then press tan, put in the 0.56, or you can put in 0.56 and press shift then tan, right? I would have to do a video showing how to use it. So tan inverse of that would give me, hold on, second, alright, hold on, I'm using the calculator on my computer, people, so bear with me. Tan inverse of 0.5 that, and then put in tan inverse of that. I get 20, get now 29.248. So let's go with 29.249. 29.249 degrees. Where is the degree sign. Here you go. Copy this. So therefore, let me just put this down here. So paste, copy the theta, this. So therefore I can say it is approximate to 29.2 when we round it off. See it? Nothing hard, nothing hard. So that's Pythagoras theorem using trigonometry, and I can go as just simple calculation. Use just the Pythagoras theorem, and this is using the Pythagoras theorem is using my calculations also. Because you see me do a series of calculation. So me cut up the triangle. So I just show you two ways in one, because you notice I made a triangle, right? Cut up the triangle. Use this vector here, get from the x-axis, go up, and then connect from the origin to this for this vertical line here. So you notice I drew a triangle, right? And then what I did now, I used Pythagoras theorem, which is r square is equal to x square plus y square. And I love to use r square because r square would be what you see as v, the 28, the whole of this would be r square. Let me take out the values and hide this. This would be r. So if I square r now and I do the little maths and I put in what I'm supposed to put in, you see I form a triangle. Alright? And that's basically it, people. That's basically it. That is basically it. Alright, so we will pick up. If you have any concern, you know where to find me. WhatsApp, Telegram. Big up on yourself. Stay safe.